Okay, so today is going to be a little different. I had to change the schedule. So if you go into the schedule, I already changed it in Blackboard, but we're only going to cover 3C, which is a short section. This will be a short lecture today. I have to get out of here a little bit early, and this was just the easiest way to do it rather than try to cram it all into a short amount of time. So today we're going to cover 3C. It goes over uncertainty or dealing with uncertainty and kind of defining uncertainty with numbers. And give me just 1 minute. Hold on. 1 second. Done. Save. Okay. So first off, do you guys have any questions from the first two sections? I know that last one I kind of had to wrap up real fast before I could move on. So are there any questions from the previous two sections? I'll give you a minute if you've got one. If you want to put it in the chat or if you want to just jump in here, that'll work. Okay. Oh, nope, but there was no comments on the test. There were no comments on your test, really, Emily? Like when you went in and saw it, let me make sure I've opened up comments. I'm going to go in right now and check that because I have been known to forget to click that button. So let me see if I just made a goofy mistake. Edit the test options. Oh, let's see. You should have feedback on there. Is there one in particular? Like the feedback would be for individual questions. And it's like, I don't know what it looks like on your side. How about just stay after with me real fast, Emily, and we can check that out. Not a big deal. I don't mind going over with you as well. Okay. Because I think we'll have time. Even when I get this done, I'll still have a little time. Yeah, I had the feedback question open. So yeah. Okay. So other than that, let's get rocking and rolling. So the first thing in 3C that your book goes over, actually 3C is on uncertainty, dealing with uncertainty. And the first thing your book goes over is significant digits, which is, I'm going to let you kind of read about it. It's not a big deal, or not that I think it's a big deal. It's more about definitions. And the main thing with significant digits is it has to do with rounding. So your book goes over there's a box in there on page 152. And there's a nice summary of significant digits. And the main thing is if there's zeros after a decimal, those numbers are significant, right? Non-zero digits are significant. The zeros between non-zero digits are significant. Zeros to the left of the first non-zero digit are never significant. And then lastly, zeros to the right of the last non-zero digit, it might be significant. I want you just look at that. I'm not going to go over it. It will be on the test. It'll be kind of an easy question on the test. So just read those first two examples in this section. Just read it. And if you're not grasping it after reading it, let me know. I'll go over it. But it's more of just a reading comprehension thing. The second part, though, is on random and systematic errors. So there's two types of errors that your book goes over, random and systematic. So a random error is going to occur exactly as it says, just randomly, right? And this happens all the time in life, all the time, okay? We just have errors that happen. We don't know why they happen. Sometimes we do know why they happen. But a lot of times with that error, you need to determine, is it just a random occurrence or is it systematic? And I'll tell you a basic example of this that I bring up with students in math all the time is when they say, I'll give you an example. I'm going to pick on my son. My son loves zooming through math problems. So I'm trying to help him. And he's like, no, I got this. And he just zooms through the math problem. But then he'll make a mistake, right? He'll call it, I just made a goofy mistake, right? You guys have heard that terminology. Made a goofy mistake. Well, the issue from a math instructor is it's hard to know a lot of times if it's a goofy mistake or a systematic mistake. So it's a goofy mistake if you just randomly forgot that 6 minus 4 is 2, right? If you wrote 6 minus 4 equals 10, you accidentally added, right? Probably a goofy mistake. But what I notice with him in particular, he'll call things goofy mistakes, but he's making them repeatedly over time. And so that's not a goofy mistake. That's not a random error. That's a systematic error, okay? If he gets something wrong consistently over time, then it's systematic and I need to work on it with them, or his instructor needs to work on it with them, or he needs to work on it. Okay. So, or probably all three, but that's the difference between a random error and a systematic error. And you can probably think of some, your book goes over really good examples. Actually, I think it has to do with the scale, you know, the scale. Yeah. When like a baby, so it's on the top of page 154, it talks about the baby's motion making the scale reading jump around is really just introducing random error, right? I mean, if you put a baby on a scale and they're just wobbling around and it's causing an error, that's definitely just random. But then if the scale reads 1.2 pounds, even when empty, you've got a systematic error, right? It's adding weight that's not there. That's systematic, okay? And your book defines it. Let's just read the definition. So random errors occur because of random and inherently unpredictable events in the measurement process. And then systematic errors occur when there's a problem in the measurement system that affects all measurements in the same way, such as making them all too low or all too high by the same amount. I can tell you the scale at my doctor's office is systematically wrong. It always weighs me lower than I should be. So it's kind of nice. And I asked them about it one time and they said, oh, it's because we take into account like what you're wearing or the weight of your clothes or something. So that really is a systematic error in that I mean, they're just doing that to kind of get an average, on average clothes weigh this much. So then your weight's this much, whatever. But it is systematically wrong, which is kind of interesting. It's kind of nice though, when I go there. Your book goes over some good examples too. I mean, it talks about the census. Look, the census you're always going to have an error in the census because there's no way we could get in touch with everybody, right? And the book says the Constitution of the U.S. mandates a census of the population every 10 years. The Census Bureau conducts a census by attempting to survey every individual and family in the U.S. Suggests several sources of both random and systematic error. So if we think about it, if you want to chime in or write in the chat what you think might be random or systematic error with the census, you're more than welcome to. But I mean, I can think of a systematic error. The goal is they're trying to get the demographics of the U.S. and they're trying to get the population of the U.S., right? So let's say a systematic error might be if they did not include a question or a checkbox maybe on the census that doesn't take into account a certain demographic, right? Like if you're looking, because one of the questions they ask is about, ethnicity and race. And so if they don't include an ethnicity or a race, but the goal is to get, the makeup of the US, well, that's going to be a systematic error, right? I mean, they're not including that checkbox on the census. Random error, though. I mean, random error, I assume I think random error might be whenever, I don't know if they harass you guys or if you've been harassed by the census, but a random error would be like if they miss somebody, right? If they just accidentally miss somebody, or they wrote, like, say the census person, it's easier just to fill it out online. They don't bother you to fill it out online. But unless your neighbor doesn't, and then they come knock on your door, it's annoying. Okay, so, but if you fill it out online and you accidentally put, like for me, if I accidentally put 3 people instead of 4, that was just a goofy, random error. Okay, so that's the difference between random. Systematic would be it's kind of built into it, right? Built into the census. And there's probably other good examples. Your book might go over more. I haven't read their answers to that, but they might go over more differences in random and systematic. And that's a really good word question on the next test, right? Explain a random error that could occur in this scenario, or explain a systematic error that could occur in this scenario. Those are really good open-ended questions. Or maybe I give you one and say, is this random or systematic? It's a good question on the test. Oh God, the coffee's just hitting better today. Oh yeah. Then it goes over, the size of errors, because, sometimes tiny errors aren't that big of a deal, right? And they're going to happen in nature. It happens. We're in humanity, it's going to happen. If I went out and tried to, get the average height of people, then the average height's out there somewhere. Well, none of us are. Well, there might be somebody that's exactly the average height, but everybody's an error off of it, right? It's a little bit up or down from the average height. for whatever, males, females, whatever it is. Okay, so error is going to occur. So your book goes over what's the difference between absolute and relative. So absolute, I'm going to just click this over real fast because we'll do some examples of this. So just like in the last section, we talked about this. So we're going to go over absolute error. So we'll call it abs. Absolute error is just when you take the measured value minus the true value. So the measured value minus the true value. And then, of course, the relative is measured minus true over true. Okay. So if, did I do an example of this? Being lazy, I can find one. Yeah. Okay, yeah, like let's say if we go to the doctor, and I told you the scale is lower for my doctor, right? So let's say I'm going to choose somebody else because whatever. We choose some, actually, hold on. Let's choose somebody, choose a Shaq. I think I use Shaq for free throws too, right? Shaq weighs 324 pounds. Okay. So he goes to my doctor though, and they measure his weight. His measured weight is, let's say, 315 pounds. So he's feeling good about it himself because he knows he weighs 324 pounds, but they measure him at 315. So if we wanted to find the absolute error, it's going to be his measured minus his true. So the measured was 315, right? Pounds, minus the true, which is 324 pounds. So it's going to be negative, right? Negative 9 pounds, right? Because that's really how the scale is off. The scale is off by 9 pounds, right? Minus 9. So then if we wanted the relative though, like how is this off? Now I'll tell you, the relative error is going to change for your weight. If that scale is just set to be off 9 pounds no matter what, right? The relative error is going to change depending on your weight, right? But the absolute error would be the exact same. So someone jumped on and they were 120 pounds, it's going to read them at 119 or 120, 111, right? So, but the relative error is going to be a little different. So if we looked at relative, it would be measured minus true, which we already found that. Measured minus true is negative 9 pounds over the true weight. Now his true weight's 324, right? Oh, we're supposed to multiply it by 100. I forgot to put that. Multiply 100 to make it a percentage, right? So we're going to multiply it by 100. I'm going to pop that in the calculator. Let's see here. Phone calculator says negative 9 divided by 324 times 100, negative 2.7. I'm going to round to 2 decimal places. Negative 2.78%. So relatively, he's down, or it measures him down 2.78%. But let's say someone else. Let's look at somebody really tiny. Gymnast. Wait. Gymnast is really tiny, right? Ooh, holy cow. According to Sound, the average medaling gymnast in the all-around only weighs 103 pounds. Holy cow. Okay, so let's look at a gymnast. Let's say a gymnast weighs, let's put that wrong, 103 pounds, right? So we're going to find the same exact thing. So she jumps on the scale. It turns out that on this scale, it will measure her at, when we subtract 9, right, we get 94 pounds, right? Which is really, I mean, think about this. Relatively, that's why it uses the word relatively. Relatively, this is a huge weight loss for her. From 103 to 94, she's probably freaking out a little. She doesn't need to be that light, right? For whatever reason, health reasons, whatever, muscle mass, whatever it is. Where Shaq going from 324 to 315, it's probably a good thing, right? But relatively, it's only 2.78% of his body weight. Let's look at the gymnast. So the absolute's going to be the exact same thing, right? Absolute error is going to be the same thing. It's just 94 minus 103. I'm running out of space here. Whoop. So it's still going to be negative 9 pounds, but the relative is what's different. The relative error is going to be, now remember, it's measured versus true. We already found that. That's negative 9 pounds over her true weight, which is 103 pounds, times 100%. So we wind up with, let's see here, clear 9 divided, or negative 9 divided by 103 times 100. So we get negative 8.7. If we round to the 2 decimal places again, 8.74%. I mean, that's a much larger relative weight loss, right? Or really, not weight loss, nothing. Her weight hasn't changed, right? This is just based on error. And that's the scary part, because it's just based on error. What if she changes her diet based on this error? And then all of a sudden now she's gains 9 pounds, but then that puts her at 112, and that's too much weight for her to carry for whatever reason she needs to carry it. So you have to be careful with error. Okay, you have to be really careful with error because it does occur. It's like if you watch any of those shows on TLC, like My 600 Pound Life, and they're like, oh my gosh, man, holy cow, they lost like 20 pounds in a month, right? Or 20 pounds in a week. Well, yeah, relative wise, that's not as much for them, right? If you look at the relative weight loss, it's not as much as like if kind of a normally weighted person lost, 5 pounds or so. Okay, hopefully that makes sense. So absolute error, relative error, very similar to stuff we discussed in the last section when it comes to the math behind it. Okay, so then your book goes, okay, I'm going to come back to me. Hey. Then your book goes over accuracy and precision. So now it's really describing the results. And there's 2 ways that your book goes over describing the results, accuracy and precision. And your book defines accuracy as it describes how closely a measurement approximates a true value. An accurate measurement has a small relative error. Okay, an accurate measurement is going to be close to whatever the true value is. Okay, precision though describes the amount of detail in a measurement. And I found some good examples. I just kind of Googled the difference between accuracy and precision. So I'm going to share my screen real fast just to kind of show you what I found, and we can talk about them with this example. Hold on. There we go. Okay, so this is one of the first. I just did a Google image search for it. But if you notice, like if the true value is in the middle, we've got a precise measurement. Now this one's not accurate because it's not close to the true value, right? It's precise because they're all clumped together. Okay, they're all clumped together. So therefore we have precision. We don't have accuracy because this is not close. I mean, relative wise, I guess it's not too far, but it's not huddled around the actual true value. Now down here though, we have accuracy but not precision, right? It's not clumped up, so it's not precise. These are all kind of around here, but it's more accurate than here. Because if you think about this, if you took the average, if this was the middle, the average distance from the middle is not bad. If you added up all these, like think of this distance would be like, say, -1. And this distance would be -3. And this would be like -6, right? Now this would be +3 and positive like 7. If you added those all together, it would get close to 0. The relative error overall would be close to the middle. Okay, if you think of them as weight, oh, that's a great way to think of it. If you think of this as a teeter-totter, okay, and right here's the pendulum in the middle. This thing's going to weight down to the right. Where the teeter-totter here might be pretty close. If all these weights were the same, the teeter-totter might be pretty even, and that makes that accurate but not precise. Now, the C is neither, right? This is not accurate or precise. They're all over the board. It looks like the teeter-totter would lean more left because of these 3 out here, and they're definitely not precise because they're not clumped around. And lastly, when we have both, they're all tightly around the actual true value. Okay, when they're tight around the actual true value, you have accuracy and precision. Another common way to do this is with like a dartboard or for arrows, bow and arrow stuff. Same kind of thing. accurate and precise, it's going to be clumped around the center. This would be not accurate, but it's precise because they're still clumped around, right? This is accuracy because it is, the error is not bad, right? It's not that far from zero and it's closer, but then this would be not accurate or precise. And we're just off, okay? So hopefully that's a good visual on explaining these differences. Oh, no. Yeah, Weston, you might be the only one lagging. Ava or Emily, are you guys having any issues? Uh-oh. I'll give us a minute to catch up. Or yeah. Is it coming through more clear, Weston? Okay, good. Okay, good. I bet it was just something goofy. The wind blew a certain way, Weston. So that's accuracy and precision. And then the last topic your book goes over in this section, again, it's going to be a short day. The last topic your book goes over is combining measures, measured numbers. And I just want you to read that. It talks about just different rounding rules. And this really combines, no pun intended, with the significant digit rules at the beginning of the section. So it just says, look, if the rounding rule for addition or subtraction, you round your answer to the same precision as the least precise number in the problem. And then for multiplication and division, you round your rule to the same number of significant digits as the measurement with the fewest significant digits. So I want you to read that first section, or the first part of the section with significant digits, and then get to that, then read through the combining measures and look at the example. It's really a basic topic to go over, so that's why I'm going to leave it up to you guys to read it and grasp it. And if you have questions, ask me, no big deal. And I don't mind going over it after you've read it. Okay. So that is it for today. It's a quick section. Quick section. I have to get out of here by 10 o'clock. That's why I wanted to at least go over 3C. So again, we're going to go over, if you look at the schedule, we're going to go over 3D and 3E on Monday, and then we'll be good to go for the test. This will be a short test. This isn't a lot of sections for this test, which the last one didn't have a lot of sections either. Okay, so I'm going to stop the recording here. Emily, stay on because I know you had a question. I want to go over that too. And if you guys want me to